Topic 4, Lesson 10 on Production Systems. Sophisticated production systems are transforming the way products are made. Economies of scale. As a business grows in size and produces more units of output, then it will aim to experience falling average costs of production. It becomes more efficient as it uses inputs to produce a given level of outputs. For example, if you're a one-off production, you're just making one of the items, it's going to be very expensive. But as you make more and more of the items, it gets cheaper because of economies of scale, until you find that sweet spot where you're able to produce enough of your product at a good price. Now, what's considered diseconomies of scale is when you're overproducing at not optimal levels. So you might think of a vaccine. If it comes out when you're in the middle of a pandemic, you're going to be producing this stuff as fast as you possibly can, and the price is probably not going to be the optimal price. Maybe if it was really driven by supply and demand, okay? Because maybe you're having to buy additional materials and you're having to pay a premium for those because your suppliers can't give you everything you want. Okay, so underproducing and overproducing can both bring you away from your optimal average cost. Production system selection criteria. Things that you need to consider for your manufacturing. The amount of time it takes to produce it, the labor, skills and training, health and safety of those people, the cost, the type of product, maintenance, impact on the environment, and your quality management. Aim 7. The design of a production system requires a complete understanding of the product and its function and the quality of its finish. Designers need to adapt their design to be manufactured using certain methods. You don't get to decide everything. You might design a product, but then in order to get it manufactured, you may have to change things about your design to actually get it to conform with the possibilities for manufacture. Meet the master craftsman. So when we talk craft production, we are very often talking about small scale production, even one-off production. Okay, the majority of the expense incurred at this level is of labor. You are paying this master craftsman to make you your one-off product or your small scale product. Most of these expenses are for the labor, which involves the manual skills. Back in history, as we figured out how to utilize different sources of energy, we started producing mills, in this case, textile mills. They typically were built right next to a river, and the flowing water would spin large water wheels, giving us power to then run machines. Okay, so this is called mechanized production, and it's a volume production process involving machines controlled by humans, powered by something else. Textile mills are the example. Automated production, a volume production process involving machines controlled by computers. And if you look at this image right here, there's not a whole lot of people on there. Are there people in there somewhere? Probably, because you have to make sure the machines, sometimes they make mistakes. Assembly line production. Doesn't this look fun? A volume production process where products and components are moved continuously along a conveyor. And you can see that the products there probably is some kind of a conveyor, possibly, let's pretend like there is, that moves the products through. And at each area or station, certain tasks are done. The product goes from one workstation to another. Components are added until the final product is assembled. Mass production. The production of large amounts of standardized products or production lines permitting a very high rate of production per worker. Again, we've got Coke because they're fun. And we've got, I'm pretty sure this is root beer. Mass customization. We talked about this once already. but we'll talk about it again. Sophisticated SIM systems, which is computer integrated manufacturing, that manufacture parts to individual customer orders. Benefits of economy of scale, because it's mass produced, are gained whether the order is for a single item or thousands. This was off of Nike's website with one of their shoes, the Air Max 90, and you could buy them for only $175. But what the cool thing was, you got to pick what you wanted yours to look like. So there were certain things that you got to put into the system. They mass customized it for you, and it showed up at your house. Computer Numerical Control, also known as CNC. It's computer control of machines for the purpose of manufacturing complex parts. Machines are controlled by what we call G code, or sometimes G&M code. The codes control the X, Y, and Z movements and the feed speeds. And if you took the robotics and manufacturing class, you know exactly what we're talking about, because you probably learned how to run the mill, the CNC mill, and the CNC router. And these probably look somewhat familiar. And you probably even know what a few of them are. So here are a bunch of G codes, here are a bunch of M codes. If you didn't take design and manufacture, you probably have no idea what I'm talking about, but that's all right. Design for manufacture. There are 4 focuses under this umbrella. You have design for materials. So are you designing using plastics or metals? Because it will determine how you design your parts. Are you designing for a process? For example, is it going to be machined? Is it going to be plastic? Is it going to be injection molding? Are you designing for the assembly so that components fit to other components, or components fit into subassemblies, and do the subassemblies now fit into the complete product? Or are you designing for disassembly? So when it becomes obsolete, it can easily and economically be taken apart. The components can then be reused or repaired, or the materials can be repurposed or recycled. Sometimes design for manufacture will include all 4 of these aspects. Sometimes it might just include a few of them.